Alright, so for chapter 6, we will talk about the discrete random variables. Right, so for discrete random variables, actually we don't know what is the discrete, right? But we know what is the variables, right? So we keep talking about the variables. We say the variable can be a quantitative variable or a categorical variable. Right, so we say we divide all the variables into two groups, either the quantitative variables if it is a numerical value and for measurements, right? Another group we call it is the categorical variable. Actually, you have the responses belongs to different groups, right? So actually, we can divide all variables into these two types of variables. Right now, we use some other way to divide the random variables. Right, so we say if all possible outcomes can be listed, then we call this random variable as a discrete random variable. And if a random variable that can take on any value between two values, then we call it is a continuous variable. Right, so that means the variables also can be divided into two types, either a discrete variable or continuous variable. We just use another way to divide the variables into another two groups. Right, so either discrete variable or continuous variable, depending on whether you can list all possible outcomes. So if you can list all possible outcomes, then this variable is called a discrete variable. If you can not list all possible outcomes, then it is called a continuous random variable. So for example, for discrete variable, for a variable, you can only take 1, 2, 3, right? Or 3.5, something like that, as long as you can list all possible outcomes. But what about continuous? For example, you can take any value from 2 to 3. That means you may have 2.1, but you can also have 2.11. You can also have 2.111. So as long as you have more and more accurate results, you cannot always list all possible outcomes between 2 and 3. There are many values between 2 and 3, right? That you cannot list all possible outcomes. Then it is called the continuous random variable. Okay, so now let's look at some examples. The first example, age. We say A, when we talk about the age, normally we mean that you are 1 year old, 2 years old, 5 years old, 10 years old, until maybe 100 years old, 101 years old, 25 years old, right? So actually you can always list all these possible outcomes, right? You can always write out 1 year old, 2 years old, 3 years old, and keep going on. For example, 100 years old, 101, 102. Right, so you can list all these possible outcomes. So the age will be discrete variable. All right, now let's look at the time. When we talk about the time, let's say from 2 hours until 3 hours, actually in this range, there are many possible time between 2 hours and 3 hours, right? Just like what we said in this example, right? We can have 2.01 hours, we can have 2.001 hours, we can have 2.0001 hours, right? So we can list the time until, let's say, until the seconds, until the minutes, right? Until the seconds, and even we can have until the milliseconds, right? So as long as you want the time as accurate as possible, you can have many decimals that you cannot list all possible outcomes between 2 hours and 3 hours, right? So actually this time will be continuous. You cannot list all possible outcomes in a range. All right, so what about distance? We say, when we say distance, we say from 2 meters to 3 meters. Right, so actually from 2 meters to 3 meters, we actually cannot list all possible outcomes. We can have 2.1 meters, right? We can have 2.01 meters. We can have 2.001 meters, right? We can have 2.00001 meters, right? So depending on how accurate is your measurements, you can always have many possible outcomes that you cannot list them out, right? So actually distance is also continuous. All right, so next one will be the shoe size. Let's talk about the shoe size. Right, so when we talk about the shoe size, can we, right, so let's erase this. Right, so for the shoe size, you can have either 5, 5.5, 6, 6.5, something like that, until maybe 10.5, 11, and so on, right? But before 5 and 5.5, do you have any other possible outcomes? Do you have 5.01 size? Do you have 0.02 size? Actually, no, right? So actually between these two values, you cannot you just don't have any other values. You don't have any other possible outcomes, right? So you can always list them out because they are limited, right? So for this case, the shoe size will be the discrete random variable. Right, so again, for the weight, what will be the weight variable? So actually when we talk about the weight, we can actually from, let's say, 2 to 3 pounds. Right, so between 2 and 3 pounds, we can always have many possible outcomes. Right, we can have 2.01 pounds, 2.02 pounds, you can have 2.001 pounds, right? You can have many decimals after 2, and actually you have many possible outcomes between 2 pounds and 3 pounds. You cannot list them out, right? So actually weight is continuous variable, right? Next one, the number of cows in a farm. So you may have 1 cow, 2 cows, 3 cows, but between 2 and 3, you don't have any other possible outcomes, right? So you can always list them out. Even though you have 10,000 cows, you can always list them out, right? Because there's no unlimited decimals between 2 and 3 or 3 to 4, right? So you can always list them out. Then it is a discrete variable. So another one, temperature, right? So we can have 30F, right? We can have 30.01F, right? So if our measurement technique is very accurate, you even can have 0.001F, right? So actually temperature is also continuous. Right, next one, ISA exam 1 score. So we have ISA exam 1 score. So actually each question will be either a whole integer value, for example 1 credit, or I can give you half credit for 0.5, right? So you may not have a score which is 78.0001 value, right? So actually exam 1 score will be discrete, right? It doesn't matter how many of the possible outcomes, as long as you can list them out, then we call it is discrete variable. It doesn't matter how small is the range, as long as in the range you can not list all possible outcomes, then it will be continuous, right? So actually we can get a general idea, right? So we say the time is continuous, the distance is continuous, the weight is continuous, the temperature is continuous, right? So actually most of the measurements will be continuous because we have more and more accurate techniques to measure these variables, right? So most of the measurements based on the techniques will be the continuous variable, right? But I said most of it will be not 100%, right? So you still need to decide by yourself whether you can list all possible outcomes. All right, and then for this chapter, we'll just focus on the probability model for the discrete variable. So for the variables that you can list all possible outcomes out. Right, so since you can list all possible values, all possible outcomes, then the set of all possible values and their associated probabilities will be called the probability model or probability distribution. Right, so this is your second time to see this word, distribution. Still remember where we see the distribution? We have the marginal distribution, we have the conditional distributions, right? So we have the marginal distributions, we have conditional distributions. This is what we are familiar with, right? So actually when we talk about the distribution, it is a list of percentage, right? So now if we list the probabilities with all possible values, then it is called the probability distribution, or we call the probability model. All right, so now let's look at the first example. All right, so this table is the probability model for a particular life insurance policy. All right, so what does that say? For a life insurance policy, for a policy holder, what will be the outcome? Can death, right? Can be disability or neither. So actually I can list all possible outcomes. That means this variable is a discrete variable that I can list all possible outcomes. Right? And then based on each outcome, I have a value. Right? So that means for the death case, then the insurance company will pay $100,000 out. And then you will have the corresponding probability. That means you have 1/1000 probability chance to have the death case. Right? And the insurance company will pay $50,000 for disability with this probability. That means you have 2/1000 probability to have the disability that the insurance company will pay $50,000 out. And then if this policyholder don't have death or disability, then it would be belongs to another category, which is neither, right? That means the insurance company don't need to pay out anything, will be pay out $0, and then we will have this probability. That means if it is not death, not disability, will be neither, right? So now you have this probability to have this outcome. Now we have the outcome values and corresponding probability. Then this is the probability distribution or probability model for this life insurance policy. Right, so actually for the probability distribution or model, actually you contain two things. The first one will be all possible values. The other one will be their corresponding probabilities. Right, so you have the possible outcome and their corresponding probability. All right, so now let's look at a second example. Right, so a second example is saying that a student pays $1 to play a game. So what is this game? Actually, it is a very easy game. You just flip the coin, right? So we say if the fair coin show hat, then he will win $4. However, if the fair coin shows tail, then we will lose $3. All right. Then show the probability model of the amount of money he had after the game. Right. So actually think about the whole process. Think about the whole game. What will be the outcome for this student? He can either win or lose, right? So if right, so that means he will either win the game or lose the game, right? So actually now this is the possible outcomes. Then we need to assign the corresponding values for each outcome. All right, so that means if this student win the game, then what is the amount of money he had after the game? So we say he will win $4, but remember this student paid $1 to play this game, right? So actually at the end of the game he will have $3, right? He wins $4, but at first he paid $1 to play this game, right? So actually the outcome for win will be $3, right? And then if he lose the game, that means the fair coin shows the tail. Then he will lose $3, right? And at the first, the student also paid $1 to play this game. That means totally he lose $4 totally, right? So actually what this student have after the game, so actually he has negative $4 because he lose $4, right? We use negative to represent it, right? So either have the $3 or lose $4, and then we will list their corresponding probability. We have the probability if he win the game, that means he will have a head, right? If he lose the game, that means he will have the tail, right? So what is the probability of head? Will be 1/2, right? What is the probability of tail? Another 1/2, right? So this will be the probability model of amount of money he had after the class, after the game. Most of the time, we also have this question say how much he gained from this game. It will be the same question, right? So after the game he gained $3. After the game he gained negative $4. That means he lose $4, right? Okay. So this is the probability model. We have their corresponding outcomes, and then we assign values to each outcome, and then we assign the different probabilities for each outcome. All right, and then to be a valid probability model, each probability, of course, will be from 0 to 1, right? So any probability cannot be 0 or cannot be negative, cannot be over 1. All right, and then we also need to make sure the sum of all the probabilities of all possible outcomes should be 1, because remember, for the probability models, we define it as list all possible values, all possible outcomes, and their corresponding probabilities, right? So we say what? We say the probability of all possible outcomes, which is their sample space, will be just a 1, right? Okay. So actually, the first job for you, once I describe this case, once I describe this game, you need to know how to make this probability model out. All right. And then next thing is, once we have a probability model, we want to know the expected value of this variable. So what is the expected value? Expected value is the weighted mean of this discrete random variable, right? So actually this weighted mean, we can also consider it is the weighted average, right? So let's come back to the first example, right? So we say that the life insurance company will pay $100 for the death, but for this death, you only have this small probability, which is 1/1000 probability, right? And then for the disability case, you have 50,000. You need to pay 50,000 out, but you have again small probability, right? So now, if for a long term, that means if this company keep running with this policy for a long term, for a long time, what is the expected average for each policyholder? How much this policy will pay out for each policyholder? This is what we care about, right? So actually, let's look at this. We need to calculate this expected value. So this expected value is their weighted average, weighted mean, or we call it is a kind of a long-term expectation. Right, so we say if this insurance company keep running for a long time, then how much money you expect to pay for each policyholder. Right, this is what we care about, right? So then we need to calculate the expected value. So what is the expected value? We have the formula of the expected value. We say the expected value, we use the E of X. So this X is the variable's name. We just use X to represent the variable's name, right? So expected value of this random variable equals to, still remember this sign, right? So actually this is the summation sign, right? So it is the sum of this term. So what is this term? It will be this X will be the outcomes, right? And their corresponding probabilities. Right, so that means for each outcome, you have the value times its corresponding probability, and then sum together. Summation of each outcome times their corresponding probabilities. Right, then this will be called the expected value of this discrete variable. Normally, we also write this expected value as mu of X. We say the mu, this is called the mu, right? So we call this is the mean or the expected value of the variable X, right? But it is not the simple mean, simple average. It is not X bar or Y bar. It is the mu of X, right? Don't get confused. Right, so let's just look at the example we just talked about, right? About this insurance company, about this insurance policy, right? So we say we want to know that if this policy keep going, then how much money you need to pay out for each policy holder on average, right? So we need to look at their expected value, right? So we say we still write down the formula expected value of equals to summation of X times their corresponding probabilities, right? So that means we have three possible outcomes, right? So for the first outcome, you have the value of the first outcome is 100,000, right? So this is your X times its corresponding probability, which is 1 over 1,000. All right, so this is the value for the first outcome. All right, and then for the second outcome, you have what? You have 50,000 times its corresponding probability, which is 2 over 1,000. So this is for the second outcome, right? And then you will have the third outcome, which is 0 times its corresponding probability, which is 997 over 1,000. Right? And then remember the last step will be the summation, right? So we need to add up all these three terms, add up all of these three outcomes. All right, and then just to calculate this, you will have this term is 100, right? This term is still 100, and last term is 0. So actually you have $200. So what does this $200 mean? It means we expect that this insurance policy will pay $200 on average, right? So this is the expected value of this discrete variable, right? So that means if this policy keep running, keep going on, then we expect that this policy will pay about $200 on average. All right, let's go for the second example, right? So we say this student want to play a game, right? So we want to know if this student keep playing this game, it would be good for him or not good for him, right? So how much money he can win, he can gain from this game on average, right? So that means we still need to calculate the expected value, right? So again, we have the expected value equals to summation of the outcome times corresponding probabilities, right? So we'll have two possible outcomes. The first one will be 3 times corresponding probability, which is 1/2, right? For the second outcome, you have -4 times corresponding probability, which is also 1/2, and then get addition, right? Summation of these two terms. And then you will have 3 times 1/2, which is 1.5, plus next one, -4 times 1/2, which is -2, and then you have -0.5 dollars, right? So what does that mean? You have a expected value of a negative value. That means if this student keep playing this game for a long time, many times, we expect that this student will gain -0.5 dollars, which means he will lose $0.5 on average, right? So that means this game is not good for him, right? So he will lose $0.5 on average if he keep playing this game for a long time, right? So at the end, he will lose money. That means he should not play this game at the beginning, right? Okay. So this is a not good game for him, right? Okay. So now we talked about the mean of it, mean of this variable. Next topic, we'll talk about the standard deviation of this variable, right? So when we talk about the standard deviation, there are two things, right? The first one will be the standard deviation, and standard deviation will equals to what? Will equals to square root of the variance, if you still remember, right? Or we can say the variance will equals to the standard deviation squared, right? Okay, so what is the standard deviation for a discrete random variable, right? So this is the formula of the variance, right? Once we have the variance, we can square root of the variance to get the standard deviation. All right, so now let's look at how to calculate the variance. We say we still have this summation sign, right? Within the summation sign, we have this term for each possible outcome, right? So that means for each possible outcome, we have the outcome value minus mu. Still remember what is mu? Mu is just our expected value, right? So actually, we say to find the standard deviation, we still need to use the mean of it, which is the expected value of it, right? So we use the first possible outcome minus the expected value squared times the corresponding probability for each outcome, right? And then you do one by one, and then at the end you sum of all the outcomes to get the variance. Right, so once you have the variance, then you can do the square root of the variance to get the standard deviation. All right, so now let's go through this example again. Right, so it's still about this life insurance policy. From the last step, we have already got the expected value, which is our mu equals to $200, right? On average, we expect this policy will pay out $200 for each policyholder. All right, and then to find the standard deviation, kind of a risk. Standard deviation will be how these payouts spread out, right? Okay, then we'll have the variance of this variable will be equals to, let's write the formulas again, right? So we have the variance of x will be the summation of each outcome minus the mean of it, expected value of it, squared times the corresponding probability. All right, to be easier, I just add another column, is called the deviation. Right, so we just call this term as the deviation. Right, the difference between the outcome and the mean of it. Right, so we have the outcome x, so this is the x, this is the probability of x, right? So we have the x minus the mean minus the expected value, which is this deviation, right? For this outcome, we have 50,000 minus the mean. For this outcome, we have 0 minus the mean, right? Then we will have 3 deviations, right? And then to calculate the variance of this variable, we just square of this deviation, right? In the formula, we square of this deviation and then times corresponding probability, right? So for the first outcome, we square of this deviation times the corresponding probability. We square of the deviation times the corresponding probability. Right, we square this deviation times the corresponding probability. All right, and then the last step is get the summation. Right, and then if you calculate this, this is your variance of this discrete variable. All right, and then if you square root of the variance, you get the standard deviation. So you have the standard deviation is $3,867.82. Right. So if you don't want to add this column, then you can actually just calculate by hand. Right. So for example, the variance by this formula, you have for the first term, you have the x, which is 100,000, minus the mu, which is 200, squared times the corresponding probability, which is 1/1000, right? So this is for the first term. The second term will be the x, which is 50,000, minus the mean, squared times the corresponding probability, which is 2/1000. And then the last term will be the value, which is the outcome, minus the mean squared times the corresponding probability, which is 997 over 1000. All right, and then the last term will be just to make the summation. Right, so there are two ways. You can just list them out one by one, or you can just add another column for the division. Will be easier for you to figure out for each term, right? So I don't think I have any preference, right? Just depending on which way you like. Right, so for the second example, let's do another practice for the variance. So let me just write down the formula again, right? So we have the variance of x equals to the summation of each outcome minus the mean, which is the expected value, squared times the corresponding probability. Right, so from the last practice, we have already got the expected value of this student will get negative $0.5 on average. Right, so what is the variance? That means we have for the first outcome, we have 3, right, minus the mean of it minus the mu, which is negative 0.5. right? And then squared times the corresponding probability, 1/2. So this is for the first term, right? You have the x minus the mu squared, right? Okay, and then times the probability of x, right? So this is for the first outcome. Sum with the second outcome, which is you have negative 4 as the outcome x, right? And then minus mu is negative 0.5, and then squared, right? And then times the corresponding probability, which is 1/2, right? And then you will have, after calculation, you will have it as 12.25. All right, then what is the standard deviation? The standard deviation will be equals to square root of the variance of x, right, which is square root of 12.25, which is 3.5. Got it? Right, so this is the formula of calculating the variance, and then once you have the variance, you have the standard deviation. All right, so now we know how to calculate the expected value of x. We also know what is the standard deviation or the variance of x. Right, and then next we want to talk about some properties of the expected value and the variance. Right, so these are very important properties of the expected values and variance. Right, so actually you need to remember them. All right, okay. So first, what if you add a constant c to the variable x? For example, your x values is 1, 2, 3. And now for each outcome, I add 3 for each outcome. So that's for each outcome, I have 4, 5, and 6. Then let's just think about what will happen for the expected value. We say the expected value is the mean is kind of the weighted average, right? So if you add 3 to each outcome, that means your average will also increase by 3, right? So that means if you adding or minus, so here adding or minus, right? So if you are adding or minus a constant c to a variable x, right? If you have the x plus minus the constant c, then the expected value will be just the expected value of x plus minus c, right? So we say if you plus a constant to the variable, then the expected value of this new variable will be just the expected value of x plus a constant. If you minus c, then it will be expected value minus c. All right. Then what will happen to the variance? So variance, it will be how these values are spread out, right? So think about our simple example. From 1 to 2, the deviation is 1, right? From 2 to 3, the deviation is also 1. When you add 3 to every value, that means you have 4 and 5 and 6. That means the deviation is still 1 and 1. So actually, the data, these values spread, the level of spread out is actually keep the same, right? So the distance from each values will keep the same. So that means that the variance also keep the same, right? So we say if we add a constant c to the variable, then the variance of x plus minus c will keep the same, right? No difference for the variance, right? So if the variance will keep the same, of course, the standard deviation will also keep the same, right? So now let's do a summary. We say if we add or minus a constant c to the variable x, the expected value will be plus or minus c, but the variance and standard deviation will keep the same. No difference, no effects from the constant c. All right, so this is adding or minus. What about the multiplying? If I multiply x by a constant a, right, so that I have the a times x. For example, I still have 1, 2, 3. Now I multiply 5 to each outcome. That means I have 5, 10, and 15. Right? Right. That means if I have 1, 2, 3, then I have the average is actually 2, right? If I multiply by 5, that means 5, 10, 15. If you get the average, that means you will have 5 plus 10, which is no, it will be 3 here, right? So the average will be 3. Here will be 15. Is that right? Sorry, just the hand doesn't work. Right, so if we have 1 plus 2 plus 3 would be 6. 6 divided by 3 would be 2, right? But if you have 5 plus 10, which is 15, 15 plus 15 will be 30. 30 divided by 3 will be 10. So that means if you multiply 5 to each outcome, so that you have 5, 10, 15, that means your average also times 5. Right, so this is the idea. So if you have the x and multiply by a constant a, then the expected value of ax will be a times expected value of x. Right, so if you have the expected value of 5, 10, and 15, it will be just equals to 5, this 5 times the expected value of original x. right? So this is the multiplication. Now what happened to the variance? Right, we say the variance, the original deviation is 1, right? But if you times 5, your deviation will be 5 and 5, right? So now the spread out of these values getting much larger than the first, or than the original data set, right? So the variance of AX will be A squared times the variance of X, right? Because the variance is the square of the deviation, right? So if the deviation just change from 1 to 5, then the variance will change to A squared times the variance of X. Right, so again, if the standard deviation, if the variance changed to square of A squared times the variance of X, the standard deviation of it will be just the standard deviation of AX will equals to square root of variance of AX, right? You will have square root of A squared times variance of X. And then we'll have absolute value of A times square root of variance of X will be just the standard deviation of X, right? So we'll have absolute value of X because square root of A squared will not be just A, it can be negative A, right? So we want to make it positive. It will be absolute value of A times the standard deviation of X. Right, so now let's just make a summary of the multiplication case. All right, so we say if we multiply X by a constant A, then the expected value of AX will be A times expected value of the original X. Right, the variance of AX will be A squared times the original variance. Right, and then the standard deviation of AX will be absolute value of A times the original standard deviation of X. Right, so these two are the properties. If you add a constant to X minus a constant to X, multiply a constant by X, constant A to X, or divide, right? So if A is a fraction, it will be dividing, right? So it will be no difference. All right, so now what if I have two variables? I have variable X and variable Y. If I have two variables, then we'll have an addition U for the expected value of the two random variables. Right, so we say expected value of X plus minus Y will be just the expected value of X plus minus expected value of Y. For example, if I have one variable X, have the outcome 1, 2, 3. I have another variable Y with the outcomes of 4, 5, 6. Right? Then the expected value of X plus Y will be expected value of X plus expected value of Y. Got an idea? All right. Then what happened? This is about the expected value, right? What happened will be the variance, right? Then we have the addition U for the variance. But when we apply this rule, we need to make sure these two variables are independent, right? So we say if these two variables are independent, then we will have the variance of X plus Y plus minus Y will equals to the variance of X plus variance of Y. Right, so here see the difference. We say for the expected value, here is plus minus, then here is also plus minus. That means we have two cases. right? We have expected value of x plus y. If these two variables add together, then you have expected value of x plus expected value of y. The other way, if you have x minus y, then you have expected value of x minus expected value of y, right? So this is plus minus. But for the variance, if you have variance of x plus minus y, the sign here is always plus because the variance is squared of the standard deviation. So it doesn't matter it's minus or plus, it is always plus. Right? So that means you will have two cases that the variance of x plus y will equals to the variance of x plus variance of y. The other way, if you have the variance of x minus y, you also have the variance of x plus variance of y. It will not change the sign of it. Right, so it will still be plus because the variance is squared of standard deviation. So even though here is minus, after you squared it, that means it will be just still positive. All right, and then of course the standard deviation will be square root of variance x plus variance of y. All right, so we say the standard deviation of x plus y will be will be square root of variance of x plus y. Right, so now it will be changed to that. Right, so here I need you to be careful that sometimes you may remember this as we say standard deviation of x plus y equals to standard deviation of x plus standard deviation of y. Can you do this? No. Right, remember you can only calculate the standard deviation by the variance. You do not have this formula. You do not have the standard deviation of x plus y equals standard deviation of x plus standard deviation y. This equation doesn't exist. Right? You can only calculate the standard deviation from the square root of variance. All right. So now let's just go through this example again. Right, so example 1 about the insurance policy. Right, so we say we have already got the expected value of x, which is 200. We also get the variance of this variable, which is 49. It's a long number. Right? Okay, then question, if the payout amounts are doubled, what are the new expected value and variance? If the payout amounts are doubled, that means if x changed to 2x, right? So what will be the new expected value? That means you have expected value of 2x, right? By the property, right? So if we multiply x by a constant a, so a here will be 2, right? And then the expected value of 2x will equals to 2 times the expected value of x, right? So that means the expected value of 2x equals to 2 times expected value of x will be 2 times expected value of x, which is $200, right? We will have $400. Good idea. Right, then what will be the variance? The variance of 2x, remember we have the property. If we multiply x by a constant a, then variance of ax equals to a squared times the variance of the original x, right? So that means our variance of 2x will be the 2 squared times the original variance, which is 4 times the variance here, right? So it would be 5960,000, right? So if you calculate this, you will have 59,840,000. Right, so this is your variance of the new variance if the payout amounts are doubled. All right. So now, one more question, right? What is the expected value and variance on 2 independent policies at the original payout amount? What does that mean? That means you have policy 1, you have policy 2, 2 independent policies. But these 2 policies actually are the same. They pay out the same amounts for the 3 outcomes. Right, so actually these 2 policies are the same. Now, actually, you are paying for these 2 policies. Right, think about it. What will be the expected value for the 2 independent policies at the same payout amount? You may think these 2 questions actually are the same thing, right? So this one are doubled, but this one actually they are the same, and then you pay the same amount. That means you still actually sum of these 2 policies, right? But these 2 actually are the same thing, right? So actually it equals to expected value of x plus expected value of y. Then since these 2 policies are the same, they pay the same original payout amount. That means you have $200 for the first policy and then $200 for the second policy. Then you still have $400. Now you have 2 independent policies with the same payout amount, right? So that means the expected value will be the summation of these 2 policies. All right. Okay, now what will be the variance? Remember, by the property, we say if these 2 variables are independent. We say if these 2 variables are independent variable, then we have the variance will be variance of summation of these 2 variables will be the summation of these 2 variances, right? So that means your variance of x plus y will equals to the variance of x plus variance of y. Since these 2 policies are the same, right? For the first policy, you have the variance of 14,960,000. And then for the second variance, you still have 14,960,000. And then you will have 2,992,000. All right. So here is the problem. Here is the question, right? So actually, if you pay double, would that be the same with if you have 2 policies, you just pay for 2 policies? So which one has the smaller risk? Which one have the smaller, which one is paying the more stable amounts? This way. Right? So if you separate your money into 2 policies, you have more stable payouts. But if you double your amount in just one policy, you will expect on average will be the same, but you will not be as stable as the second option, right? You have more variance. So this is the difference between these two. So now think about the whole process, right? So we say if your pay amount are doubled, that means you pay $1, now you pay $2, right? And for the second case is you pay $1 for this policy, you pay another dollar for the other policy. So actually you pay the same thing, you still pay the $2 for the insurance policy, but actually you are getting payouts more stable. Right, so this is the case you need to think about if you will work in the insurance company in the future, right? So in the doubled will increase the risk to pay more to have the larger variance, right? So here we say if in this case the expected values are the same, but the variance are different. All right, so we'll just stop here for today's class.